Partha Dasgupta doesn't need he's an economist. He is an economist. Everybody knows Partha Dasgupta. For example, it's a personal regression, I started to study environmental economics after reading a book, a famous book of Partha called The Control of Resources, published in 1982, where I was so fascinated by that I decided that I should have to study those topics. Partha has contributed in a lot of areas. In discounting, he wrote a very important contribution. I hope that you will refer here. I must mention that recently Partha has also been the president of the European Association of Environmental and Resource Economists that gather all those economists who are interested in this area. So Partha, the floor is yours.
Thank you very much. It's a great honor to be here today. Some of us, I don't know if the young have the same kind of attitude as some of us older people have, which is those of us who are secular, we still have a religion. I do have one, and this is one of those temples. My religion is scholarship and science in its most general form, and coming to a place like this makes me feel cleaner than I normally feel. So it's a great honor to be here, sir, and in this hallowed place. Professors Rinaldi and Musu have together given us an overview of the kinds of issues that we are concerned with here. I think they've done a terrific job, actually, summarizing various aspects of the problem. Is this being?
Maybe you have.
I need this, do I, for recording? Is okay? Fine. I'll try and keep to. Today, what I want to do is talk about discounting, because that's the theme. But I want to do it from a slightly unorthodox position. There's nothing unorthodox about what I'll say. These are mathematical theorems, so they cannot be challenged, unless I got them wrong, of course. So it's not that. The unorthodoxy is the route which I will take to try and understand some of the difficulties that society faces with our interactions with nature. It is a common place to think that perhaps we shortchange future generations. Very often ask, are we not being overly selfish in our craving for goods and services when Mother Earth is being tormented in the way she is? And it's harder to reconcile this position regarding future generations from our natural attitude we all have, at least those of us who are grown older, for our children. They're direct descendants, and it's very hard to see the sense in which parents have neglected their children in terms of putting in savings for them. Think of the investment we make in their education, health, general transmission of culture, whether it's through the grandparents. These are qualitative observations, obviously, but they're important. I'll tell you, and I'll come to in a minute as to why they could be important and why existing models are inefficient in picking these features up. So you might say, well, given the fact that we care about our children, never mind the future generations. But of course, if you care about your children, 2 seconds of thought tell you that they in turn will care about their children. So if you really care about your children, then by recursion you'll be taking into account your grandchildren's and your great-grandchildren's and so forth down the generations, and you might say, well, we're halfway down the route of Frank Ramsey, which Professor Musu was thinking about, namely we take the whole future into account in some sort of way. Natural affection for one's children is so powerfully ingrained in us that it's something that we really ought to take on board. Okay, well, if that's true, just qualitative. That's true qualitatively, if nothing else. Why then are we in such a mess? The standard route of the economist would be, it's because we are underpricing natural capital. Markets are missing. And if markets are missing, then obviously you do not economize on cheap goods, you economize on scarce goods, pricey goods. So if Mother Nature is underpriced, you're going to have a bias in the direction of usage. And that's the kinds of issues that these were the points that were being made by Professor Rinaldi and Musu in turn, and they were absolutely correct. There's one caveat though. We have a tendency in the West to think of any kind of resource allocation failure as market failure. Because there is a tradition in political theory, as well as in political economy, to think about essentially three institutions: markets, the state, and occasionally households. But in economic models, typically the household is a black box. You don't study the internal workings of the household, but you do spend an awful lot of time looking at the internal workings of markets. And political scientists, of course, try and understand the state. In fact, the huge amounts of natural capital is under the jurisdiction of communities. And we forget that communities are an extraordinarily important institution in the world as we know it. In rural communities, of course, it's rampant. Markets are missing all over the place, but that doesn't mean that people aren't negotiating with one another. Social norms, customary behavior grew to not replace markets. That would be the error that we economists make. The moment we see something which is outside the market, we say it's there to correct for the failure of the market. It's not that. It's that people have to live in society, socially. The importance of transactions arise of that need. So environmental problems that we were thinking about here are due not only to market failure, but institutional failure in general. And the institutional failure could be the failure of the household, inside the household, gender relationships, for example, or the biases in gender relationships. If you think, let's start with that. If you think about the trade-offs that are involved in resource allocation arising out of the fact that women are responsible for cooking, fetching water, collecting fuel wood with the children, where the men do, let us say, in an agricultural community, agricultural work, you can see immediately the kinds of distortions in investment strategy, conservation strategy that would arise. And I have written extensively on that, but I'll then there are communitarian failures that occur through a variety of reasons. Some of them could be stresses arising out of public policies which go awry, or the state usurps the authority of communities, particularly the early stages of nation building, as happened in Africa, and there's a huge amount of evidence of that. And if the state can't replace the jurisdiction of communities appropriately, why then again you will have very easy to see how you could have mismanagement of the local commons, which may have been arranged in the past reasonably well, but no longer are so because the jurisdiction has changed by fiat. So you can have communitarian failure arising out of a huge number of forces at work, and some of them have been documented. There's a very rich literature emerging not within economics to begin with, but more from anthropology, but anthropologists weren't trained to think of everything as resource allocation problems, which of course we are we think of them in our sleep, we economists. So that combination of the two has been very useful, I think, in trying to understand rural poverty in Africa, South Asia, and so forth. And then, of course, there is government failure. It goes without saying. So I would argue that there is, generally speaking, we should be thinking of institutional failure, and we identify the nature of the character of the institutions and see what biases come from them. Which leads me to my talk, which is these failures could be summarized, and I've been trying to do that in my recent writings, into a general theory of what is a very old notion of externalities. So I'm going to try and give you a general sense of externalities, a very general definition, but it's sharp enough that it picks up all the threads that we have in mind. By externalities, I mean the unaccounted for consequences for others, including future people, of decisions made by each of us. Okay? These are the unaccounted ones. So something is missing in the transactions that are taking place, and that missing item I'm going to call externalities. These consequences could be damaging to others, but as they're unaccounted for, people responsible for them are not obliged to compensate the victims. Any one person would have only a very tiny effect of the global state of affairs, you could argue. After all, each of us is small. But when the effects that each of us has on others are added, and since there are a lot of us, the sum could be substantial. And that's the source of the problem. Now, what I want to do is, the next few minutes, just give you a sense of the kinds of externalities that exist and do a classification. And then I will spend the remaining 20 minutes or so of my talk developing one rather unstudied form of externality. These externalities could be are of course failure. These institutional failure or externalities is intimately connected to an absence of appropriate property rights, and I'm going to ignore that for the moment because that's rather obvious. I'm not going to be really concerned with property rights as much as the nature of the externalities. Now, the externalities that I have in mind are four types, and maybe I should start with the ones which I will not be discussing. There are technological externalities. Classic examples of externalities would be a factory belching out smoke, and the neighborhood has a laundrette, a laundry. Well, why then, of course, there is a technological interaction, and unless property rights are very well specified, there will be no compensation for the damage that the polluting firm inflicts on the pollutee. This is classic, and this has been much discussed in the literature. The second kind of externality that I'd like to just remind you of arises in fertility decisions, reproduction. And I'll come back to this in a few minutes after I develop the other things. The second one on my list over here is the one which Professor Rinaldi alluded to, the externalities that occur in our use of natural capital. And I've already alluded to the fact that natural capital often doesn't have markets or a sensible way of handling them, so that their use doesn't get recorded, or very often are unaccounted for. A substantial part of it is unaccounted for. Two types of externalities have been much studied: unidirectional externalities, which would be one kind would be deforestation in the uplands, affecting productivity of downstream farmers and fishermen. There are now very, very nice empirical work estimating that those kinds of externalities, and they can be substantial, 10, 15, 20% of output of farmers affected by deforestation that are taking place upstream. These are very hard empirical work to do because it requires collaboration amongst economists, statisticians, hydrologists, soil experts, and of course people have an understanding of forest ecology. These, I mentioned this because in a way these are really a high-hanging fruit to pluck them requires enormous amount of work. I have not been engaged in that kind of work, which is why I can praise it. It's been done by young people in various parts of India, Pakistan, and sub-Saharan Africa, but we are beginning to see that those are substantial errors that are taking place in resource allocation. And these are very hard ones to solve because the number of people who are being damaged by upstream deforestation in Malaysia, Indonesia, where some of the best case studies have been taking place, are hundreds in number. And of course, they do not get damaged at the same rate. It depends on slope, which direction you're facing, whether the rainfall is harder on your side of the hill as opposed to your neighbor, and so forth. So the damages that farmers suffer from deforestation in the uplands differ from farmer to farmer. Now you have to add up the damages in order to be able to tax the polluter, in that case the deforester. Right. So you can see why, in some sense, centralized activity has to be undertaken. Reciprocal externalities are just that. Each person inflicts on the other the same kind of externality, and that's the most commonly discussed form of externality in the use of natural capital. A work on the global commons, local commons, is all about that. Okay? Climate change is a classic example of reciprocal externalities. We each are inflicting a harm on others which are unaccounted for, and therefore they are externalities. What I want to discuss here with you, and then develop some ideas of discounting, is consumption externalities. Yes, Sai.
If I can ask a quick question.
Yes, please.
About this in an ecological framework, where, for example, an externality might be if I'm a predator and I consume a prey item, obviously that's an externality. Where would that, there are things like that in the economic marketplace too, where I exploit someone else and take.
Sure.
Where would that
All true, including consumption.
Where would that fit here?
Well, take, for example, technology. That will include the pecuniary externalities that firms might inflict on others. Sure. The exploitation side will come the moment you model the transaction that is taking place between people, whether through production, through consumption, through reproduction. I alluded to it, for example, inside the household, where the gender relationships could be extremely important in terms of the biases that result in the use of resources. So we need to look at the transaction, the nature of the transaction, and therefore the power relationships or lack of in me. Okay? So that's pervasive, and you're absolutely right for raising your question. So what I want to do is to talk about consumption here, because that's been really badly modeled in my subject, and I'm ashamed to say, in some deep sense, the theory of consumption hasn't progressed in 60 years in my subject. The last survey I read in the Journal of Economic Literature, which came out about 4 years ago, hasn't really moved beyond Ramsey. We are looking at, and I'll explain in a minute what I mean by Ramsey, so I don't want anything missing here. This conference is on, workshop is on discount rates. And so I may as well make it clear as to what I mean by a discount rate, or what we all mean by a discount rate. First of all, you choose a numeraire, a unit of account. Let's suppose the unit of account is consumption, unit of consumption. Of course, we're already aggregating a lot. There's apples, oranges, shirts, shoes, and so forth and so on. Never mind. Imagine that we can aggregate them in some way. And if you don't like aggregation, use your imagination and think of a world with only one consumption good. That's easier. Okay. So you've got a consumption good. And the question you're asking, you as a person, say Professor Musu, is wondering how to think about trade-offs between consumption today, consumption tomorrow versus consumption day after tomorrow, and so forth. Professor Musu cares about today, he cares about tomorrow. Even if he's not around, if he thinks he's not going to be around tomorrow, he thinks about his child, who will be around tomorrow, and so forth, down the generations, okay? The question that is being asked is the following. Suppose Professor Musu has a forecast of consumption into the future, and that forecast could be stochastic, of course, the point that he was raised. Never mind that, because that's not going to cause any problem for me for the points that I want to make. Imagine a deterministic world so that he has a forecast. And it could be that consumption is growing, he's an optimistic forecast, or it could be he's in a very pessimistic mood and he wants to take his actions with a view that actually there'll be bad news ahead, consumption will be declining, maybe. So never mind what that is, he has a forecast. Now he asks the following question. He asked for a perturbation. He says, suppose I were to give up 1 unit of consumption now, how much additional consumption would I deem as a reasonable trade-off for my giving up for tomorrow? Suppose the answer to that is 1 plus R. Now, R could be negative, of course. But suppose he thinks through this and he says, well, I balanced my needs versus tomorrow's needs, day after tomorrow's needs, and I have a forecast. And actually, Professor Musu already alluded to it. He said that maybe I'm thinking my forecast is that the consumption is increasing, in which case their needs will be a bit less. In which case, whichever way the direction or the bias goes, you will have an answer to the question, if I give up 1 unit today, what should R be if 1 plus R is the trade-off I'm willing to accommodate, given my values? And of course, he's thinking about this problem now as a citizen. Of course, he could also ask the question from his own perspective, taking only his child into account. And as a citizen, of course, he will also take into account then, if as a citizen he wants to think about it, he would say, what about those unaccounted for consequences? So if I have to make a trade-off between now and tomorrow, maybe it will have some spillovers on others which I should take into account. No matter which way he thinks, whether as a citizen or as a private individual, he will have an answer to the question, what's the trade-off? Let's suppose it's 1 plus R. The value of R will, of course, depend on whether he's a citizen, to repeat, whether he's a citizen or whether he's thinking of it as a private individual, whether he thinks it's going to be optimistic future, or whether he's optimistic about the future, or whether he's pessimistic, and so forth. All that's there, but there will be an R. That R is called the consumption discount rate between today and tomorrow. That's the definition. If it's negative, and it could be negative, why? Because it could be that he's very pessimistic. Tomorrow, hell will break loose. So I better say that they'll need it badly. So I'm willing to give up 1 unit for less than 1 unit additional amount for next period because they will be poorer. We do that kind of analysis when we give aid. We say to ourselves that $1 lost to me is worth less than the 50% gain to somebody else who is very poor. So we're not unfamiliar with this kind of trade-off. That's across people. This is across people, of course, but across time. That's the essential thing. So that's my definition, and not when I say my definition, it's everybody's definition, because that's the right way to think about it. That's a trade-off that you're looking at. Okay. Suppose, for the sake of argument, that you expect consumption to be increasing, but at a declining rate. And you might think that's reasonable even in classical models because of diminishing marginal productivity of capital. As capital accumulates, the return on capital will be expected to reduce because of fixed factors of production. The simplest way of introducing nature into a model. Never mind degradation, but just fixedness of capital. But if that happens, then the discount rate will be declining. So you do not need uncertainty to generate hyperbolic discounting. Hyperbolic discounting, as I'll show in a few minutes, arises straight out of a standard deterministic model so long as the rate of return on investment declines over time because capital is accumulated. That's the background. Now what I want to do is to talk about the unaccounted for interactions, consequences to others that arises out of our consumption of goods and services. The standard model in economics thinks of, well, the standard model has many, many errors in it, all of them created by Frank Ramsey. and we haven't got out of them. Standard model doesn't actually have a sense of the self. A person is to be thought of as essentially a sequence of seats of utility. So you add them up. A person's entire life is to be seen as a summation of the utilities that he experiences, let's say the well-being he experiences. And you add them up, maybe with a discount rate, but that's not the key thing, but you're still adding. The idea of an integrated whole of a life is missing there. All right. We'll stick to that for the moment, but it gets worse and worse. The utility of a person or a well-being of a person depends entirely, exclusively on his or her consumption level at that moment. So it's a flow of utilities, but the flow of utilities of a person depends exclusively on his consumption. And of course, I want to now enrich that model. Okay? The way I want to enrich it is to think alongside people who work in these fields, but who we do not usually acknowledge, who are psychologists and sociologists and anthropologists. They, at least my reading of them, gives me two kinds of people, two kinds of motivations in each of us, and we all have experienced them. One is a sense of competition with others, and the other is a sense of belonging with others. And we all experience it. And the way I will model it will be familiar to ecologists here. It'll be more in the form, it's what you, I guess, at least Cy Levin, who has taught me ecology a great deal, would call mean field theory. And it'll be interesting to see how much the theorems that I'll be giving just now in a minute, extend to a case where people are clustered, that people have neighborhoods over whom they compete, against whom they compete and or wish to belong to. I'll give you a very general model, and now I'm going to move away from this. Can I use now these, how do I do that? If I put this here, oh, this is very good. So I made these notes by hand because I thought it would be nice to, I proved a couple of results a couple of days ago, so I thought I'll put them in. Is that okay? All right. So don't think about this yet. I mean, I'll come to that in a minute. I wanted to think of an extension of Frank Ramsey's model. Those of you who know it will know what I mean. Those of you who don't know it won't know what I mean, but it doesn't matter because I'll be doing it anyway. I'm extending it. Which is, I wanted to think of a dynasty. I want you to think about a whole bunch of parallel dynasties. That's the way to think about it, but let's start with one dynasty. I'm going to index that dynasty by I, small I. And that dynasty thinks about the future, infinite horizon, children, grandchildren, and so forth, and sums up their consumptions. The only difference is this. Let me get onto the model. Now, this is going to be hair-raising for those of you who don't care for very purified models, but it's just the natural thing for those of us who like rarefied models. I want you to think of a continuum of people, dynasties, indexed in the unit interval 0 to 1. They're all identical. I don't want any externalities or divergences coming out of any other source than consumption, because it's consumption externalities I want to study. And I want to borrow from the anthropological literature to see how to create a better motivated group of people. So I have a continuum of dynasties. Small t is time, starts from 0. Capital CT, second line, is therefore the integral of each of dynastic consumptions at date t. Small c subscript I is the consumption of dynasty I at date t, integrate over I, 0 to 1, and you have total consumption. However, in order to simplify things completely, I have a uniform distribution of people of unit density, which means what? Another way of looking at it, there's only one person. Or zillions of people who are all identical to each other. And you'll see in a minute the power of this kind of abstraction. Because it'll get us all the things we want at a very cheap price. So the dynasty's motivation at any moment of time t is given by the well-being of dynasty of its u. The u function that appears in the integral on the third line is what I wanted to look at. This object here. That's the well-being, the utility flow, if you like, of the dynasty I, depends on his consumption, its consumption, small c subscript I. That's the standard bit. But now here's the non-standard bit. It also depends on the average consumption of the community. And the average is, of course, capital C, because that's the integral of the CITs, and there's only one person, so I've normalized it already, so that's it. So I've got two things going. One, the personhood matters. Others matter. And that's where capital CT is introduced. Okay? That's it. That's the only generalization I'm going to make, but it's going to be quite powerful for our purposes. Delta is positive for obvious reasons, but if it's zero, it doesn't matter. The theorems that I'll be giving you will go through even for zero. Social welfare is the integral of dynastic welfare, so that's hardly worth mentioning. And because households or dynasties are identical, at everyday t, CIT is the same for all I, and it's equal to the average capital C. Okay? Now, here's the dynamics. We have to think of this world, there's no labor. And after I give this talk, we'll talk about what happens when you have leisure in it. And what about Veblen and so forth. And I'll come back to Veblen later. But for the moment, we have a single capital asset, K, standard production function f of kt. F of kt is GDP, output, minus CT is the accumulation condition. Left-hand side is dk/dt, which means it's net gross investment, no depreciation here. It doesn't buy me anything, so I'm not going to have it. So the dynamics of this world is as given in here. F prime is positive, that means the rate of return on investment is positive. F double prime is negative, the problem is concave, which means declining marginal product. And of course, that will give me declining discount rate, as you can easily intuit. All right, you don't need very much more than that. All right, so that's the setup, and I can be now quite prompt. I want to think about two solutions to this problem. One in which each household or dynasty chooses, each member of the dynasty at zero, chooses without concern about his choice of consumption on others. Remember, the utility function of each household is, I'm sorry, I got this wrong here. Where am I? Here. Each household is UCT, capital CT. So when a particular household chooses consumption level, it's going to affect the average. Now you're going to say it's going to affect the average with zero measure. But that doesn't matter. There's a unit measure of people. So the sum is going to be substantial, or it'll be non-negligible, which is a point I've already made. So I want to think about two solutions to this problem. One, in which there is no state, so the solution is a market one, in the sense that each household chooses its consumption program, or each dynasty chooses its entire consumption program without taking into account its effect on the average consumption, although the average matters. So it takes the average as given, so it's like a Nash notion, Nash equilibrium notion. And we want to look at the dynamic equilibrium of this, so that's one solution. And the other is to see if there's a problem with it, if there is a distortion, if there's some failure of resource allocation, in which case, what's the best thing to do? So now let's start with the current value Hamiltonian. It's U plus a price that you attach to capital asset. That's the shadow price, PT. That's standard. And you end up with a necessary condition, which is classical calculus of variations. Number one, equation one, it says the auxiliary variable, this shadow price, the percentage rate of change of the shadow price, P dot is dP dt, by the way. So it's the percentage rate of change of the price should equal to delta minus Fk. You may find that odd, but it's not. I'll tell you in a minute what it means. Minus the rate of change of P is what I've been calling the consumption discount rate. Why? Because if you look at it, you'll see that this will be this for that, this, and then plus that. And the right-hand side gives you the rate at which, this is an optimization world, remember? The household is optimizing. It's not the global optimum, but each household is optimizing. And what it wants to do is to equate its consumption rate of discount, which I have already defined for you earlier, with the rate at which it can transact with nature. And here, nature means the production function. So this equation number one is absolutely fundamental to any optimization exercise. It says the rate of return on investment on the right-hand side equals the rate of discount of consumption on the part of the optimizing agent. Okay? This is universally true for any optimization exercise. And it immediately tells you that if the capital is accumulating, then Fk is declining over time, then the right-hand side will be declining over time, and therefore you've got your declining interest rate, or discount rate, which people have been talking about previously. I won't belabor it anymore. Okay, now I want to contrast two alternative scenarios. One in which, as I suggested, argued before, I want to think about a world with the externalities, that the externalities are not corrected. Each household makes its decision based on rational expectations about others' behavior. Since it's identical households, it's not a big thought that people will be making the rational expectations. And in which case you get equation number two. It says at the margin, the price, the shadow price of capital will equal the marginal utility of consumption. Small. This is small c. So it means its own consumption. Remember, it doesn't take into account the effect of small c on capital C, on the average. This is the unaccounted for consequences. This is the world with the externalities, with the consumption externalities. And you get equation 2. The small m I put up is to indicate that I'm looking at the market solution, i.e. the one with externalities. Okay? So that's equation 2. Now consider the optimum, that is a social optimum. I'm going to put a superscript O on it. Now there, we are looking at a government which is trying to maximize total welfare, taking into account the fact that average consumption is the same for all households. Therefore, the equation that the government will be choosing is equation 3. It will take into the shadow price of capital, which I've written here as P superscript 0, will equal the contribution that consumption makes to the representative household's utility, given the fact that the representative household cares not only about its own consumption, that's this, but also on the average consumption, which is this. But of course, the two are the same in equilibrium, which the government has recognized. Okay. Now, compare 2 and 3. Immediately, alarm bells go up because you know something is wrong with the decentralized world. Nothing big deal about it. It's obvious, intuitively obvious. No household is taking into account the fact that it's affecting the average. And since there are lots and lots of these households, the total distortion could be substantial. This is standard stuff, comes up even in matters like climate change. Each of us spews some carbon into the atmosphere. We don't have to pay for it. And we say, what does it matter? I'm nothing. I'm one of millions of people. But of course, there are millions of people making that same calculation, and then the sum becomes substantial, and we worry about the matter. And that same phenomenon is taking place here, except for one thing. I haven't said anything about how U depends on capital C. What's the nature of the externalities? And that's what I want to discuss with you now, in a minute.
Or there's a possibility that the social optimum is asymmetric?
No, not in this. It's a purely concave, strictly concave problem. Yeah. I haven't given the details on the U function, but F I've already given. So if it's strictly concave, it's no. All right. Now I'm going to, this is typical of the first part of the remainder of my talk is based on a paper that Ken Arrow and I published a few years ago, and of course our first question was, under what conditions are market outcome and optimum the same? Obviously, if U subscript capital C is 0, then it will be the same, because that's a standard problem. That's a standard Ramsey world with no externalities. But could it be otherwise? So here was the condition, and then we'll talk about the special cases. The market and the optimum are the same if the P dot M upon P is equal to P dot O upon P, then of course the two will be moving in the same way. Why? Because think of the two islands with a identical, except for the fact that in one there is a government which is optimizing, in the other it's the Nash. They start with the same capital assets, same level of capital, same utility functions. Then if the consumption rate of interest in the market is the same as the consumption rate of interest in the optimum, then of course it'll be the same rate of accumulation, so the two will be the same. So the question arises, under what condition is 4 correct? Now I want to look at two cases, and these are the two externalities that I mentioned earlier in competitive consumption and conformist consumption. In a very famous book called Conspicuous Consumption, Theory of the Leisure Classes, by Veblen back in, I think the edition that I remember reading is 1924, but he read it some previously. He was writing about the Gilded Age, which we are now revisiting these days, with the Russian oligarchs and so forth. The Gilded Age of people with enormous amount of wealth and spending money on, you name it, to show their social status. So the idea here we're picking up is pretty straightforward. Competitive consumption, that's case 1. U subscript capital C. When the average goes up, a person feels worse. That's negative. Okay? So that's what it is. The derivative with respect to the second factor in the utility function is negative for all small c capital C. That's the Veblen case. A very general formulation. On the other hand, now I can't make this distinction here because there's only one consumption good. But if we think about our own lives, there are cases where we do compete. Perhaps those of us who feel more academically oriented, we compete then on a different thing, like the quality of our papers. We sometimes feel bad when somebody else writes a paper which we wish we had written ourselves. That kind of thing, that's a Veblenesque notion. But at the same time, and that's something that's been missing in pretty much the entire literature in economics as far as I know, which is the fact that we also like to belong. And it's, I think, a very interesting and important research program to see the nature of the commodities where we actually do our associational, that create our social capital, if you like, to use expression that is quite familiar in Italy, and in which we choose to compete. Friends of mine have told me that we compete on things like the watches, quality of watches. This, by the way, was £10 only. So it sort of lasts about 5 years, and then you have to buy another £10 watch. But as you know from advertisements, there can be watches for £23,000, £25,000 easily these days. On the other hand, we do socialize. We want to be like others. And one example, just to clarify what I mean, is examples where we in Cambridge, it's quite customary to invite friends to dinner. And we like giving dinner parties, and of course we enjoy attending dinner parties with our friends, in fact. Now, one of the interesting features of it is that you never, but never show off. That is to say, the quality of the food and the wine that is offered is pretty much the same across. Now, you might say, well, presumably it's the same because pretty much the same income levels. You're all badly paid professors. But it's more than that, because you're competing, on the other hand, on other objects. But here, there is a kind of idea that you want to be like others. And I want to pick up that feature here. And that's my case B, social consumption. Here, capital U subscript capital C, that is the average, marginal utility of average consumption of others, is greater than 0 if the typical person's consumption is less than the average. Do I mean that? No, I mean just the reverse. I mean just the reverse. I'm sorry. I was doing this morning. So, that. I'm very sorry. Got it wrong. So if my consumption exceeds the average, then I feel better if the average goes up. Whereas if my consumption is less than the average, my utility goes down if the average goes up, because then I'm farther off from that. All right, so that's the setup. Now let me give you the theorems, final theorem, and then we can stop. Consider A, that is, we are looking at competitive consumption, and that's the case that Arrow and I considered. We found, it's easy to show, that if there exists a negative number between 0 and -1, such that the marginal utility of average consumption, when the consumption average and is the same for everybody, is proportional to the marginal utility of one's own consumption, this is small c, then there's no distortion. And you can see why, because if you'll remember the first order condition, if I can get hold of it. Yes, you can see why. Because if this is proportional to this, then of course this will be proportional to that. Say, suppose this is proportional to this for all C0t. Then this will be proportional to that, and therefore this will hold. Equation 1 will hold. So the question arises, it's an interesting case because it says that even though you're competing in such a way that it doesn't matter, there's no distortion. Now, let me give you the solution in a more intuitive way. So I'm competing against others. Everybody is competing against everybody else. So there is naturally you would think there is a tendency towards overconsumption. Because everybody wants to beat the Joneses. And the Joneses want to beat everybody else, so everybody is lifting consumption. Somehow or the other, in some direction. So you might think there'll be overconsumption, which is the point that led Veblen to think about this problem. But here's the problem. If you care about tomorrow, and if you consume too much today, then you fear that tomorrow you'll be beaten by your competitors. The Joneses will beat you. So you have a trade-off between being happy having beaten the Joneses today versus being unhappy tomorrow by being beaten by the Joneses. And so that trade-off needs to be considered. And the condition I've given you, which is where this is proportional to that, just says the two arguments cancel each other. And in equilibrium, it's optimal. Yeah.
Is necessary and sufficient?
Yeah. Necessary and sufficient. That's why I think I wrote down if and only if. Yeah.
Doesn't it affect the consumption discount rate? Because even if the two shadow prices are different, the rate of change
is the same, so the consumption rate, discount rates are the same. That means that they track the same development path, so there's no distortion. Okay, well then of course it suggests to you that you are in a knife-edge case and you need to do empirically to see where the bias actually takes place, and one can do that. The overall theorem is as follows. I'll give it to you now. Suppose leisure is another commodity, so you extend the production function to include labor. Veblen's talked about conspicuous consumption, and conspicuous there had actually a dual role. One was that it's conspicuous, showing off. And the other one is that everybody can observe it. So now suppose leisure is unobservable, but consumption is observable. Then what Arrow and I showed was then you get an unambiguous bias towards excessive consumption and too much work. People work like crazy in order to be able to consume like crazy in order to beat the Joneses. Okay. And of course, there's a very beautiful book by Juliet Shore, the sociologist in America, The Overworked American. So the theorem that we proved was to show how the nature of this competitive consumption, when at least one of the consumption goods is not observable, and therefore you can't compete, it goes without saying. That's the whole point of the exercise. You get this bias. Notice excessive consumption, all these externalities, the ones I haven't, number two, the use of natural capital, these are related. If there is excessive consumption, the burden of that excess will fall on the cheaper factors of production, which is the environment. So again, the assault is on environment. No matter where you come in terms of the nature of the externality, at the end of the day, the burden, the pressure, is on the environment. Okay, let me finish by then showing you I think really rather, I found it quite interesting because I wasn't expecting it. What happens in the other case where there is social consumption? Well, where there is social consumption, remember the condition is that if my consumption is less than the average, then if the average goes up, I feel bad because I feel isolated. I'm more distant from those I care about. On the other hand, if my consumption is greater than the average, then if the average goes up, I feel good because now I'm more like, or the others are more like me. So therefore, what happens is when the consumption are the same, of course, the derivative is zero because it's switching from negative to positive. When Ci is equal to capital C, then U of capital C subscript is zero. The distortion vanishes. So in this case, in the social consumption is the one case where, at least in this extreme model that we've studied, or at least I've studied, suggests that there is no distortion because people are trying to be like others and are moving in the same direction. Okay, final remark. These two types of externalities that I've talked about, social consumption and competitive consumption, if we convert them into the language of game theory, here the game is very straightforward. You've got a continuum of people, so there's hardly any strategic behavior. There is no room for strategic behavior. Each is minuscule, and it just adds up. The equilibrium is easy to characterize. You don't have to think too much about it. But it pays us to think about the nature of the environment in which you have competitive consumption and you have conformist consumption. In competitive consumption, your intuition would be that we are really in the realm of a prisoner's dilemma game, or generalized n-person prisoner's dilemma game, akin to the commons problem. Each is trying to beat the others, there's a distortion, and the only way you can do something is to say tax that consumption good, so everybody restrains. But in the absence of that taxation, agreements on their own won't be worth anything because each will have an incentive to try and beat the others, and therefore there'll be excessive consumption. So it looks like a PD game, and in fact it is a PD game, a prisoner's dilemma game. And the solution is very similar to the ones we've already studied in other contexts. What about social consumption? Now that's quite interesting. Turns out, at least I'm pretty satisfied with the examples that I've seen, it's not, of course, it's certainly not a PD game. That's quite clear from the way social consumption is defined, that each wants to be like the others. It's a coordination game. And so you can, there are some extreme examples of coordination games or social consumption that some people have studied. They're called solidarity consumption. These are called solidarity goods. It's not my term, it's the sociologist's term. The idea here is that extreme case. It's not that I care about the good. I don't care about it at all. It doesn't matter to me. But people I care about, I want to belong to or belong with, care about it. They're doing it. And so I consume it too. Classic example, at least the ones that they were cited in the papers I read on this, are taking part in marches, protest marches. I don't like protest marches, I don't care about it, but I want to be with my friends who are engaged in protest marches, so I'm going to join them. Now, it could be that you equilibrate with everybody going on a protest march. We can then see how it could become, this kind of thing could be a coordination game, that average consumption is what it is because it is what it is. It's like an equilibrium is by its own bootstrap. People have chosen it. People find themselves in an equilibrium in which average consumption is some level C star. And I'm keen to consume C star because I want to be like others, but then so is everybody else keen on it. So we end up in C star. Whereas if nobody really cares about that good, then you might all be better off not consuming it at all. Unless, of course, it's serving some purpose, like a protest march and so forth, in which case, of course, you do care about it. So the nature of the externalities, and these two types of externalities that I've talked about today, in this very simple kind of model, but it just does clarify the thing, are very different. One is a coordination game, and the other is a PD game. And like coordination games, in a symmetric situation, the ideal solution is also in equilibrium. And that, I think, is what was reflected in the dynamical model I've just now presented, where if you have this social consumption, then there is no distortion. So if we were to sum up, if we're more like the Italians, we care about getting together in the piazza and chat and not work so hard, maybe there is hope for us after all. Thank you very much.
Thank you very much. I think it was a really stimulating contribution. Maybe I was thinking about extending that to the reciprocal, the natural environment externalities, maybe. I don't know. It's anyway, I don't know, Andrea, shall we have a few minutes if there are some question and answer before having a short break? Maybe somebody wants to raise some question or to... Yes.
Well, I am comfortable with the idea of 1 unit of consumption. Because if you consume different goods or different services, so you might have different expectations. Should I repeat? Okay. I'm uncomfortable with the idea of 1 unit of consumption. It seems to me that it's really a bit too theoretical because you have different goods, different expectations. So can you comment on that?
Sure. That's a very good question. If the utility functions are identical, that was the key assumption. The key assumption wasn't one good. It's really that they have the same utility function. Then you can solve the market equilibrium very simply by looking at the representative household and seeing where the distortion arises. If you have multiplicity of tastes, then of course each household will have a separate equation of its own, and all hell breaks loose. Even in simple, timeless world, these are general equilibrium problems are hard to solve. On an intertemporal world like this, it's of course doubly hard. So what happens if you have a multiplicity of goods, but identical people? As I was suggesting, Arrow and I looked at one class of cases. You have a vector of consumption goods, M of them, but one inconspicuous consumption good, leisure. We thought of leisure. Well, actually, these days, even leisure is conspicuous because you see it in these big ships that go through channel. That's leisure, but it's very conspicuous. People will tell each other, yes, I went to Venice on this boat and so forth, so that's conspicuous. And you mean you haven't? And then you immediately get worried, next year you get onto such a similar boat. So suppose one of them is inconspicuous. Then one can show, under very general conditions, that there will be excessive consumption of these M goods. Well, now what form, what proportions will be in each of the M, we don't know. But every one of them will be overconsumed relative to the optimum. Okay. So if you like, the essence of the problem doesn't lie in the multiplicity of goods, But it lies on whether some goods are not observable, and therefore you're not competing against them. Of course, it could also be, and typically is, all these goods may be observable, but you're competing against only on some of them, not others. And I like to think, in the world that we live in, we compete on some goods, and we want to be sociable on another set of goods, and maybe there's a third category over which we don't care what others are doing. And there'll be a mix of biases, one arising out of the fact that the second category would be like coordination game, and therefore is not going to cause a distortion. First category, there is a distortion because of the existence of the third category. So long as not all of these are Veblen goods, you have potentially a serious problem of overconsumption, of bias. Now, so now you start with a model in which everybody's identical, and then you say, well, that can't be right. So you tweak the model a little bit. By continuity, if they're slightly different, the result continues. It's very heterogeneous, hard to tell. It's impossible to tell, in fact, because some people might be competing on one commodity, others are competing on some other commodity, and you never know. I dare say if our very smart econometrician friends who work on consumption, if they did some serious work, like they will come up with some aggregation theorems telling us the direction of bias depending on the nature of the aggregation that's being done. But as I say, there is nothing in the empirical literature, econometric empirical literature today, which goes anywhere near to any of this. So I don't feel embarrassed about having identical consumers and a single good, because you don't get this in the literature now yet.
So if I may, just
please.
On the fact that that's a parallel with ecology as well, because the identity of consumers is the concept of identity of consumer is it's an interesting one, actually. So I was wondering, it's very clear that processes would maintain the same behavior under different levels of aggregation are very special processes, in fact. So have you thought of how the aggregation, in fact...
kinds of things I have been thinking a little about, but I haven't got quite the technology that you guys have at my disposal, is the following. I think we can really start working, this model I think is pregnant with possibilities, because you could have now clusters. Suppose the commodities over which you compete, or the commodities in which you want to be like others, depends, endogenously of course, on your capital asset, how wealthy you are. Then if you have you construct a model in which there are different wealth categories, and people of the same wealth cluster around each other, so some intervals, that you're not competing against somebody who is a businessman, because you don't care about the business. What you care about is Simon, or Dasgupta, or something like that, okay. Oh, Simon, all right, Simon. Right. And likewise with the businessmen. Then you would get clustering of these activities, which is exactly what we observe. That's not a problem. But I think getting the technicalities of such models in place, because there are too many endogeneities here. Because the worth of your assets depends on the allocation of resources, and therefore the clustering itself is endogenous to the pricing mechanism that's revealing. But it could be doable. I can't see any intuitive reason as to why we can't have a general theory of stratification of a society, and therefore the differences in consumption behavior. Why some groups go to the opera, some groups go to the football matches, and some groups go to both, and so forth and so on. We should be able to do that through this kind of activity. Because without them, you won't be able to get a theory of an account of it.
So sorry, but to iron out inequalities in the process.
Yeah, that's right, exactly. Yeah. Sorry.
Maybe this is related to the last question, but it seems I think about analogies in the non-human world. It seems to me there are lots of situations where the concavity assumption will break down. Situations in which there are benefits in having a lot of the consumption concentrated in some subset of the individuals. And I'm thinking about eusociality, for example, in the social insects or something of that sort. Now, maybe if you take the units right and think of it in terms of fitness, things become symmetric. But it seems to me I think it's a beautiful framework, but it'd be interesting to me to extend it to situations where the concavity breaks down, where the second derivative is actually positive, where there are advantages to aggregation, and where you may get non-symmetric solutions in which a few individuals get most of the consumption because there are externalities, if you will, that feed back to benefit everybody in the long run.
That's very good. What you're suggesting is, I mean, I'm not going to do this until size getting old, the young could pick this up and solve the problem, which is, what you're saying is absolutely correct, which is the rate of return on investment will differ. Suppose you bring in a bit of human capital in it, that's one possible way of doing it, is that the productivity, what he was saying is the productivity of different groups, different types may be different. And then, of course, you will have the kind of result that you're seeking, a differentiation, a stratification of society. Remember, everything that I said lends itself to discussion in terms of the discount rate, because I gave you the formula for the discount rate. So if there's a bias in the market relative to social optimum, the discount rate is different. A private discount rate is different from the social, and of course the bias is in exactly the direction that we were imagining. That is, excessive consumption means that your discount rate is high relative to. Okay? Any other questions, or I think we're running out of time anyway.
No. Do we have 5 minutes break and then we start with Simon? Okay, thank you.